This is just a sample of the training available at itdvds.com. To see complete training, please go to itdvds.com. Let's begin the sample. The Open Systems Interconnection Model, or OSI model, is very, very important to know, not only for the test, but in the real world. And we're going to be referring to it a lot throughout this training. Now, the OSI model was developed for the purposes of standardization. Before the OSI model, we had a lot of vendors developing proprietary networking protocols for their equipment. And that was fine as long as we were using all of the equipment from one vendor. But what about if we needed equipment from one vendor to communicate with equipment from another vendor over a network? Well, a lot of times that was a problem. It just didn't work because each vendor had their own proprietary networking protocol. Well, the OSI model helps standardize protocols so that equipment from one vendor could communicate with equipment from another vendor. Also, the OSI model helped to divide network communication into smaller components. A classic example of this is an office. For example, your office probably has an HR department, an accounting department, an IT department, and each of those departments have a specific function. In whatever department you work in, most likely you just focus on that particular function. Well, the OSI model did that with networking and networking protocols so that a protocol only had to handle a specific function. This is much easier than handling network communication end-to-end, just as it's much easier than handling all of the office functions like HR, accounting, and IT. So if you had to perform all the functions of those different departments, it would be very difficult. But performing the function of one department is easier. The OSI model also prevented changes from one layer from affecting other layers. And let's take our office example again. We may have a policy in IT that we change, but it doesn't necessarily affect the accounting department. So they don't have to worry about it. And vice versa, the accounting department may make a policy change from within their department, but it doesn't affect us in IT. Well, in networking, we can make a change to a protocol, and as long as it adheres to certain standards, it doesn't affect other protocols. So we don't have to go change other protocols that it interacts with. Also, the OSI model really helped with troubleshooting because if we know what layer, and we're going to be talking about layers in a second, if we know what layer a problem occurs at, then we know what protocols to look at first. So let's take a look at this OSI model. The OSI model has 7 layers. Layer number 7 is the application layer. Layer number 6 is the presentation layer. Layer 5, the session layer. Layer 4, the transport layer. Layer 3, the network layer. Layer 2, the data link layer. And layer 1 is the physical layer. And we do refer to layers by these numbers. So it's important to know that layer 2 is the data link layer. Layer 7 is the application layer. We have to memorize the layer numbers and the layer names and their functions. So let's start with layer 7, the application layer. This is going to provide your user interface. And we're going to take a look at what protocols function at each layer in a bit. Layer 6 is our presentation layer. This presents the data and handles the processing, like encryption. Layer 5 is the session layer, and this keeps different application data separate. So if you're working in 2 different applications that are talking over the network, the session layer makes sure that the application data is separated. Layer 4 is your transport layer. This provides reliable or unreliable delivery and also performs error correction. And when we talk about reliable or unreliable, that can be a bit confusing, but it'll become a lot more clear when we delve into TCP and UDP. Also, layer 4 is responsible for flow control, acknowledgement, and sequencing, and we're going to get into that a lot when we talk about TCP. Layer 3 is your network layer, and this provides logical addressing. In an IP network, a logical address is an IP address. And the reason it's logical is because a physical network adapter can have different IP addresses. It can have multiple IP addresses, so that makes it logical. Layer 2 is our data link layer. This combines packets into bytes and bytes into frames, provides access to media using MAC address, and also performs error detection and not correction. The correction actually happens at layer 4. Layer 1 is the physical layer. This moves bits between devices and specifies voltage and wire speed. So this is actually the physical media that you're networking across, like an Ethernet cable. It's very important to know in detail what each layer does, what protocols are used at that layer, what the data unit or the protocol data unit is at each layer, and also the networking devices used at each layer. But when we're talking about networking with Cisco devices, we're really going to focus on layers 1 through 4. But again, we do need to know each layer. So let's go over each layer. We're going to start at layer 7, which is the application layer. The data unit at this layer is going to be the actual data itself. And we'll get into this a bit more in a second. Let's look at the protocols used at the application layer. And this is just an example of a couple. There are a lot of different protocols that are used at the application layer. FTP, NNTP, HTTP, and Telnet. Now we might think that at the application layer, something like Internet Explorer actually exists. Well, Internet Explorer isn't on the application layer. It is, in fact, an application that interfaces with the application layer. An example of this is if we open up a local HTML document that's just on our desktop with Internet Explorer, it doesn't actually interface with any of the application layer protocols. So it doesn't interface with HTTP because we're opening a local document. The path to it is most likely like C:\users \, and then whatever the path is to that HTML document. But if we type in HTTP:// into Internet Explorer, then it's going to interface with the application layer because it's using the HTTP protocol. Let's take a look at an example of this real quick. So here I am on a Windows 7 machine. I've got an HTML file on my desktop. I'm just going to double click on it, and I'm using Internet Explorer. And you can see the path to the HTML file is C:\users itdvds1 desktop test.html. But I'm not actually interfacing with the OSI model. But I am using the application Internet Explorer. Now what about if I type in http://itdvds.com and hit enter? Now I'm working with the OSI model because in order to retrieve this document via HTTP or the Hypertext Transfer Protocol, it had to be done over the network. So Internet Explorer actually interfaces with the application layer first. The application layer is also responsible for identifying and establishing the availability of the intended communication partner and determining whether sufficient resources for the intended communication exist. The next layer, layer 6, is going to be the presentation layer. And this layer is responsible for data translation and code formatting. So it's kind of like a translator, so that if any conversion of the data needs to happen, it happens at the presentation layer, such as encryption. And some examples of some protocols that work on the presentation layer are MIME, TLS, or SSL. SSL we're probably familiar with. If we go to a website that uses HTTPS to encrypt the data as it gets sent to and from the server, the actual encryption process happens at the presentation layer. And it's important to know that we can move down the OSI model or up the OSI model. So when I made a request on Internet Explorer, I started at the application layer, and the data is moving down as my request is getting sent then over the network to the server, which was our itdvds.com server, and then it began moving up the OSI model. So for example, if we're using SSL, when I made the HTTPS request, it gets encrypted at the presentation layer and then gets handed down to the session layer. When it gets to the server, it's vice versa. So it goes up, and the presentation layer now decrypts it and hands it to the application layer. And then this process is repeated. The server is going to send data back to our Internet Explorer. So that is going to go down. It's going to get encrypted down the OSI model, and then it's going to reach our computer, go up the OSI model, get decrypted, handed the application layer, and Internet Explorer is going to actually show it to us on the screen. The next layer, layer 5, is the session layer, and this layer is pretty simple. It just keeps the information separate between applications. So if I've got multiple applications running, the session layer makes sure that the data that comes back on the network gets handed off to the proper application. An example of some protocols that work at the session layer are NetBIOS and NFS. So at this point, layer 7, 6, and 5, the data we're working with is just the data. So it hasn't been what's called encapsulated with networking information yet. And we'll get into encapsulation much deeper later on and go over actual examples of encapsulation. But just know that at layers 7, 6, and 5, the data is still just data. The next layer is layer 4, our transport layer. And now we're getting into the actual networking part of our OSI model where the data is done being manipulated and we're going to encapsulate it, that means surround it with actual networking information so that it can be sent to the proper place, the proper destination. The transport layer actually segments the data into data streams as it goes down the OSI model, and then when it goes up the OSI model, it actually reassembles those segments to hand them to the session layer. This layer can also establish a logical connection between the sending host and the destination host. And we're going to talk about how that works much more when we talk about TCP. The next layer is layer 3, our network layer. And at this point, our segments are encapsulated and they become packets or datagrams. And this layer is responsible for logical addressing. So in an IP network, it would be an IP address. This is also what layer routers function on. It's very important to know layer 3 is where routers function because routers route packets based on their IP address. Some protocols that work on layer 3 are going to be IP version 4, also IP version 6, which we're going to be talking about as well, ICMP, and there are other protocols that work at layer 3. But these are the main ones we're going to be focusing on. The next layer is layer 2, our data link layer. And at this level, our packet is encapsulated and it becomes a frame or a data frame. And this level is where switches and bridges function at. And they use MAC addresses to actually send the data to the correct physical device. So layer 3 uses logical addresses. Layer 2 uses the physical MAC address that is actually burned onto the network card. And some of the protocols that function at layer 2 are going to be Ethernet, 802.3, ATM, SDLC, HDLC, PPP, PPTP, L2TP, IEEE 802.11, Token Ring, and FDDI. And then finally we have layer 1, which is our physical layer. So this is the actual media that our bits are transferred across. So something like an Ethernet cable. The protocols are 802.11, Ethernet physical, so your actual Ethernet cable, 100 base TX. We're going to talk about that in a second. There are lots of different type of physical Ethernet cables, DSL, SONET. And hubs work at our layer 1, our physical layer.